with the measurement of central tendency. So what does measurement of central tendency does? So measure of central tendency is trying to find out an average single item which represent the entire data of a series. So average an attempt to find out one single figure to describe the whole figures. So average provides us the fast gist and give a bad eye view about the huge mass. Like when you have a, like if I'll give some 10,000 data, if I'll tell me give some like impression about data. So if you will not use any techniques, it is very difficult to tell about the data. So you need one techniques to tell the gist of the data. So the measure of central tendency is one of the measure where you have actually measure mean, media, and mode. So where actually you trying to give some gist about the data. So what it is does, so it try to give an impression about how your data is like behaving. So there are 5 types of measure of central tendency. One is arithmetic mean, we call it simply is mean. Then second is median, the third is mode, the fourth is geometric mean, and fifth is harmonic mean. So the arithmetic mean is trying to calculate the average figure of a data. So there are different types of series is there: individual series, discrete series, and continuous series. So in these are the like formula, the summation x by n or a plus summation n. Like in individual series, like discrete series also you can calculate by summation fx by n. And for shortcut method, a plus summation fd by n. For continuous series also like that. Then median actually give the middle value of a distribution, or median n plus 1 by 2. Then mode is the value that is that which is actually show the greatest frequency of that series. Also you can find out the mode by 3 median minus 2 mid. Then the fourth type of measure of central tendency is the best for the average of percentage increase. So GM is defined like when the percentage increasing, so you use the geometric mean. So it is defined as the nth root of product of the nth item. So there also you can use the individual series, discrete series, continuous series. With these methods you can calculate. And the last items in the measure of central tendency, you have a harmonic mean. So harmonic means based on the reciprocal of the number average. So it is defined as the reciprocal of arithmetic of the reciprocal of the individual observation. So here we actually use all these methods to do the univariate data analysis. That means when you have one, like you have age as an observation, you have income as observation. So if you want to find out mean, media, mode, arithmetic mean, geometric mean, from by using these techniques you can find out. These are very basic, like when you read the basic statistics, these are things we read in the classroom. But this is required when you do the like advanced level analysis, because any research paper first, whenever you do descriptive statistic analysis, because that is the basic fundamental thing that you should do when you do when you are doing like quantitative data analysis. I have seen some of the paper, they forget to actually do the descriptive statistics analysis. At least the first things you have to do descriptive statistics analysis, and second things you have to do the correlation analysis to find out the status of all these variables. Otherwise, if you are doing like some sophisticated data analysis without doing all these things, then somehow you are misleading your reader. Okay, let's discuss the another types of like analysis of univariate data analysis, that is the measure of dispersions. So the first type of measure of central tendency, we wanted to know something about the data, and with the different techniques we wanted to give some gist or some bad eye views to the data, and we were using different techniques for different purpose. Like, but in the measure of dispersion, basically, as you know, dispersion show the measure of spreadness or the scatteredness, or the how much it deviates from the mean value. So generally, if you want to know what is the deviation from the average, we use the measure of dispersions. So in the measure of dispersion, we have a set of measures. You have a range, you have an interquartile range, you have a standard deviation, you have a variance, And also you have two important other summary, that is skewness and kurtosis. I'll just touch upon all these methods and then I will shift to the advanced techniques. Okay. As you know, range actually shows the difference between maximum value and the minimum value. So difference between the third and first quantile is known as interquantile. So variance is the average of the standard deviation from the mean. As you know, the variance is the square of the standard deviation. Why you use the variance to measure the variability? Because in standard deviation there is a negative, there is a chance that you can get the negative values. So in order to avoid that, so we do the variance. So standard deviation is square root of the variance. Okay. So these are the some of the examples from where you get the that range and interquantile range. So from the any basic books you can understand how to find out the range or interquantile range. I am not going to that because I need to do some basic like advanced exercise also. As you know, range is the maximum figure minus minimum figure, you can get range. And interquartile range, you can, when you subtract Q3 minus Q1, you get interquartile range. And these are the definition of variance and the standard deviation. So you can calculate. Nowadays, software is there that you can do, but the thing is that you should understand. For example, if somebody will ask what is the standard deviation, you can able to tell that standard deviation is nothing; it is a deviation from the mean. Then the particular particular person will understand. Yes, you know the definitions. So what is variance? Variance is the actually square of standard deviation. Let's understand another two important concept of like data analysis, that is known as skewness and kurtosis. So first understand skewness. So what skewness does? It trying to measure the symmetric of the frequency distribution. Like how like it is a normal distribution or positively skewed or negatively skewed. So if it's a normal distribution, that mean, median, mode are equal. So that is known as normal distribution, which is a bell-shaped curve. If it's like skewed to left, so that is known as positively skewed, which where mean is greater than median, median is greater than mode. In reverse, when there is that skewness, when it's negatively skewed, it is skewed to the right. So that means mode is greater than median, median is greater than mean. So it is reverse of the actual positive skewed. So the kurtosis, actually kurtosis, what it may measure? It measures the flatness or the peakiness of frequency distribution. Whether so it depends upon the beta values. So there are three types of kurtosis. One is platykurti, another is mesokurti, another is leptokurti. If the beta value is equal to 3, so that is known as normal distribution, and that is the mesokurti. If the beta value is less than 1, so that is relatively flat. So that is known as platykurti. If the beta value is greater than 1, so that is relatively peaked. So it shows the, like when you have observation is that how much height, like if it's more like peaked, so that is known as leptokurti. If it is more like flat, it is little bit below, that is known as platykurti. That means kurtosis shows that peakiness of flat, like whether it is big, like more peaked or flat, that shows the kurtosis. Or if it is normal, it's not more peaked or flat, that is known as mesokurti. But the skewness shows the like your from which side actually it is skewed. So you need to understand. One is talk about the height of your distribution, another is shows the direction to which it actually tilt. I think I'm making sense.
Sir, excuse me, sir.
Yes.
Sir, what is beta value and how it is calculated?
Beta value, that calculation is there. I am not written here. So one take that definition is there in any basic statistic books you can find out. Okay. So I think some value that I have forgotten.
It's actually calculated from the moments, I think.
Yeah, some moment value. So
yes,
like nowadays for like academic exercise, you calculate beta value. Otherwise, you prefer using any nowadays when as a researcher, you don't need to calculate by the like notebooks. Whether you are using Excel or SPSS or users data, you have to only use these options and it will give you like beta value. According to that, you can tell what is that. But if you want to teach in the classroom, that is there. From the moment you can like some M3 minus M1 divided by some formula is there. Okay, that I can check and let you know. So that is a simple that you can calculate. Okay.
Hello, sir.
Excuse me, sir.
Excuse me, sir.
It is the beta is equal to 3. It is, sir, near about 3 because I have read that value is 0.23.
Yeah. So this is how they like in a skewness.
Excuse me, sir.
Yes.
So what
Yes, please.
so what is the required range between range of kurtosis and skewness? Desired range.
Just 1 minute. I told if the beta value will be like I, for example, in a skewness, if you are doing like any distribution, if you like it depend upon what type of exercise you are doing. Okay. If you are doing simple OLS techniques, you should have actually a normal distributions. That is like when mean, median, mode equal, mean, median and mode are same. So if mean, median, mode are not same, so that is not normal distribution. So you cannot do like OLS, you cannot apply OLS techniques there. So that means that is a normal distributions. So it should be symmetric. Like in a skewness, it should not be like if it's positively skewed or negatively skewed, you cannot use like OLS techniques. Okay, that is it. It needs like contest. When I'll teach you like OLS, I'll tell you need a normal distributions. That is assumption of OLS is there. So their mean median mode should be equal. If the mean median mode not equal, that is not normal. So you need some nonlinear techniques. So that is normal. That is not that normal distributions. Okay.
Excuse me, sir. Sir,
Yes.
can you go back?
Yes.
Sir, I am understanding squidness, but I am not understanding kurtosis. So can you please explain
Kurtosis.
how it is
just-
different than squidness, kurtosis?
Actually, what I told, the skewness actually shows that to which side actually it is skewed, whether it is positively skewed or negatively skewed. Okay, like if it is a positively skewed, it is skewed to the left. If it's a negatively skewed, it is skewed to the right. But in kurtosis, what is the? It shows the like how the height, whether it is a more peaked or more flat. Are you getting the point? It is not about from which side it is. That it
Okay,
is,
sir.
yeah. Like if it is more like
Excuse me, sir.
that
How much?
so it is different. Yeah, like the use of these techniques, its skewness actually you trying to find out the
Flatness.
like whether the data is symmetric or not. Symmetric means how it is tilting to the both the sides. But the kurtosis actually shows like when it is symmetric, then whether what is the height, like whether is it more peaked or more flat. If it is more peaked or more flat, it is also problematic. It should be a normal. Beta value should be what he was telling, it's near to about 3. But if you will platycuti, then it will be relatively more flat. If it is like leptocuti, it is relatively more peaked. Okay, that is not desirable. Understand?
Okay,
So you
sir.
can-
Thank you.
So you can see this one. So this is what it is skewed to the left. So this is symmetric. That is equally distributed from both sides, left and right. Okay. So this is skewed to the right. So this is what that platycuti is that. So that means it's more flat. Then you can see this is the mesocuti, is more peaked. Can you see that? And this is actually leptokurtosis, peak distributions. That is what is actually for a normal distribution. You need a mean median mode should be equal, and it should be a mesocuti. Then that means beta value should be near to 3. Okay, clear? So
Okay,
this
sir.
was,
Thank you.
so this was all about your simple analysis of the basic analysis of data. So now I'll start like when you have a data actually how you like when you have a bivariate data how actually you use it. So basically like whether since our topic is quantitative data analysis,
Excuse
so you should understand when you have data, so what are the scales of data analysis. So basically we come across the three types of scale of data analysis. One is nominal, the second is ordinal, and third is scale data. Okay, so anybody can tell me what is nominal data?
Nominal data in the form of just like a name
Anybody
and
else
attribute.
a little bit more further explain what is nominal data?
Sir, in a qualitative data, we go about the nominal data like age, education, gender.
No,
male
no,
and
in the
female.
qualitative data also we can do, ordinal also we can do. So we do nominal data also, ordinal data for qualitative data analysis. So what is the difference between nominal and ordinal data analysis?
Sir,
Sir, in
natural
the
dichotomy.
ordinal,
Sir,
Dichotomy, then there is
sir, in the ordinal
binary-
data, we do the
binary
ranks.
data.
That can be categories into the mutual exclusive group.
Yeah. So what happens?
Sir,
The
may I?
yes, please.
Sir, in nominal data, we cannot perform, sir, statistical calculations.
Yes, you are right. So what happens in the nominal data? We cannot do the mathematical treatment or quantitative data analysis. So that's why nominal data represent the quality or attributes of the qualitative variables. What the nominal data represent? Quality or attributes of the variables. So the nominal data does not have a numerical sanctity. Am I right? Like when a data does not have a numerical sanctity, we cannot do the mathematical treatment or mathematical operations. It only represents the quality or attribute of a data. That means any qualitative figure, when we are trying to represent the quantitative figure, we take the help of nominal data. That means when we are doing gender, like male and female, we are taking 1 for male, 0 for female, or 0 for male, 1 for female. That is a nominal variable because we are trying to give one figure to a qualitative variables, where we cannot do any mathematical operation because here 1 is not greater than 0, 0 is not less than 1. Am I right? Whereas if we want to do the second types of scaling is that ordinal variables. In the ordinal variables, you have an order. Like when you have to trying to capture your education qualification. So the fifth is like if you write 0 equal to illiterate, 1 equal to 10th pass, 2 equal to intermediate pass, 3 equal to graduations, 4 equal to post graduation, 5th equal to doctoral degree. So there you understand fifth is greater than 1. Am I right? So that means the person who is a PhD holder who are more educated than who is like class 10 pass, or fifth is greater than 4. The person who is a PhD holder is more educated than a postgraduate guy. Am I right? So there, so that means in ordinal variable we can do the mathematical operations. Is it clear?
Yes, sir.
So then another type of so that we cannot do the any quantitative analysis for the nominal data. So what type of data I'll speak, either it is ordinal variable or a scale variable. So another type of data when you use the pure quantitative data, that is known as scale variables. Okay, in the scale variable we use all these quantitative, like you have a GDP, you have a saving, you have a investment, you have a gross domestic capital formation, you have a foreign exchange reserve. All this data you measure through quantitative data analysis. Okay, so the simple quantitative data analysis we measure. So when you have a generally we don't do the analysis. When you do the research, when you don't do the bivariate data analysis, we can do the bivariate data analysis, but the bivariate data analysis does not actually capture the real world modeling. Like in a research problem, like particularly in social science, you don't have any dependent variable and one independent variables, or you don't have two variables exactly. You try to find out the correlation or regressions. Okay, so before starting correlation regression, please let me explain what is the meaning of that. Then we can study the technicality and the types and what is the understanding regarding these two concepts. So anybody can tell what is correlations?
The relationship between two
It shows the
variables.
association. Simply, it shows
Okay.
the association between the variables.
And what is regression?
It shows a prediction of an average value of an independent variable from the dependent variable from the independent variable.
So that is one of the important tasks of regression. But apart from that, what regression does?
It shows that it may show the cause and effect relationship, but in correlation we does not know the cause and effect relation. Which one is cause and which one is effect?
Okay, that is another dimension. What is the another major dimension of regressions? Anyway, so you are coming close to that. Anybody can tell what is the simple definition of prediction is that? What is the another definition of regressions?
Sir, it provides an equation by which we can apply the, if you change the variable, then what is the effect on the dependent variable?
Yes, good. So as you told, the correlation shows the association between two and more variable. If it shows the two variables, and if I trying to find out what is the association, we use the correlation. That is known as simple two variable correlations. And if you have more than two variables, so you can also try to find out the association between the two variables. That is also like multiple correlation you try to find out. So I think correlation concept is clear to you. Let's come to understand like concept of regressions. So the regressions in the first, that regression basically does the three functions. One, the regression, what is the simple tax of regression, what is the in the regressions, we are trying to find out the value of dependent variable with the help of independent variable or variables. This is the first tax of a regression. That means what you are trying to understand, we are trying to understand the value of dependent variable with the help of independent variable or variables. That means if y is the function of x, with the function of x, with the help of x, we are trying to find out the value of y. Or if y is the function of x1, x2 up to xn, with the help of x1, x2 up to xn, we are trying to find out the value of y. So this dimension is known as impact analysis. What my other friends told that another important objective of regression is also it helps on forecasting also. So with the help of independent variable, if you're trying to find out or predict the value for the future, and we can also predict the value of future by getting its intercept and slope. That I'll talk a little bit later on. So let's discuss the correlations.
Sir, hello, sir.
Yes, please.
Yes, sir. My question is this: can a regression define which one is the dependent variable and which one is the independent variable, or is there any formula?
Yeah. See, you have asked very good questions. See, in a regression, which variable you will make dependent variable, which variable you will make independent variable, comes from theory itself. Okay. So when you define regression, that is the mistake we do, that we can actually restrict one variable as dependent variable and another variable is independent variable, which is not true in case of macroeconomic modeling. Any variable can become dependent and any variable can become independent variable. But in regression, since the assumption that we have to keep one variable dependent, another value independent variable, but there is no restriction we can make. In case of simultaneous equation modeling, you can keep on changing your dependent variable and independent variable. So when you keep on changing in dependent variable and independent variable, you get the different result. Are you getting the point?
Yes, sir. I'm getting, sir.
So, for example, if I'll give the example, if I'll take 4 macroeconomic variables, that is your growth rate, inflations, gross domestic capital formation, and foreign exchange reserve. All these variable has the potential to become independent variable and dependent variable. Okay, so it depend upon the context, which context you are using. If you want to find out the correlation between investment and growth, and you want to try to understand how investment is like gross domestic capital formation is affecting growth, so there you have to make growth as dependent variable and investment as independent variables. If you
Yes,
want to know how growth is impacting investment, at that time you have to make investment as dependent variable, growth as independent variable.
yes, sir.
So it become your contest, and that concept contest comes from your theory. Which theory you want to test? For example, if you want to test the Keynes psychological consumption functions, there your consumption will be dependent variable, investment will be independent variables.
Yes, sir.
So it depends upon context. So it purely depends upon context. So the no software will tell you in the world which is dependent variable and which is independent variable. From the theory, you have to define and you have to do that. And once
Yes,
you
sir,
change
yes, sir.
dependent independent variable, your variable changes. So that's why sometimes the Swamiji equation model gives a better result compared to the single equation model. Okay.
Yes, sir.
So that is the advantage of simultaneous equation model on over the single equation model. Okay.
Yes, sir. I'm getting, sir. Getting, sir. Thank you, sir.
Okay. Anyway, you are asking advanced question. Let me go there, because some of my friends there, they want to understand basic also. That also I have to give the equal
Okay,
justice to both of my friends. Okay. So the correlation, as I told, because which concept I teach, I tell the basic gist of that concept and layman concept of that. Now I'll take the technical concept of correlation and how we in the academic world, how you teach and how you should understand the correlations. That is also required. So the correlation shows the degree of relation between the variables under considerations. So that is the correlation we measure with R. So these correlations varies from +1 to -1. So if is +1 is perfect positively correlated. If the -1 perfectly negative correlation. If equal to 0, then there is no correlations. I think everybody know this concept. Okay. So in other words, correlation is a statistical tool that shows the degree of relation between the variable, or it shows the association between two or more variables. Then the second concept, you should understand correlation and causation. That is a very important concept. So causation always implies the correlation. So that doesn't mean that there is a correlation, then there is a causation. So if there is a correlation, it doesn't mean there is a causation. But if there is a causation, then there is a correlation. That is the relation between correlation and causations. Like when you talk about the concept of Ganser causality, like if as you know that I'm dragging to there. So anybody can tell me if there is a two variable X and Y. Can you tell me how many cause and effect relationship is possible? Yes. If there is two,
negative and 0.
how many possible relation, like if X and Y are two variable, what are the possible cause and effect relationship is that? One is X causes Y, another is
Y causes X.
then what is the third possibility?
There cannot be any correlation between the two.
Okay. What is the fourth possibilities? Both X and causes.
Both causes each other, sir.
So in quantitative techniques, we call it first two, X causes Y, Y causes X, we call it unidirectional causality. When X and Y, they cause both each other, we call it bidirectional causality. When X and Y, they does not cause each other, we call it no causation exists. Okay. So that means causality always implies there is a correlation, but that is correlation doesn't mean that there is a causality. So I have already spoken. So there is a positive correlation, also there is a negative correlation. So if they moves in the same direction, there is a positive. If they move in a different direction, we call negative correlation. Then you will get R value in the positive and you get R value in the negative. Okay. So it's only depend upon the sign of, like if it's positive, the positive correlation. If it's negative, that is a negative. For example, water consumption and temperatures, study time and grace, there is a positive correlation. Like alcohol consumption and driving ability, negative correlation. Price and quantity demand, there is a negative correlation. This is how. Then the second type of analysis of the correlation is the simple correlation and multiple correlation. As I told, then in simple correlation, we have one dependent variable and one independent variable. In the multiple correlation, we have in the correlation, you don't have dependent independent variable. In the correlation, you have two variables, simple correlation. Multiple correlation, you have more than two variables there. Okay. Also, the correlation, you have two types of correlation. One is linear correlation, another is non-linear correlation. So that means in the two variables, if they move in a pattern, we call it a linear correlation. In the non-linear correlation means that the two variable there is no pattern is followed, like one variable is going up, another is going down. So big up and down is there, we call it non-linear variable. That means the proportion of change are not equal between the variables. If the proportion of change are equal between the variable, we call it linear correlation. If the proportion of change or percentages are not equal, or that call it non-linear correlations. So sometimes there are three types of like techniques, so through which the correlation you find out. One is scatter diagram. Simple scatter diagram, you can understand whether they have a correlation or not, or you have a Pearson correlation coefficient, that is with the R, summation xy by summation s square. From that you can calculate the correlation coefficient, and there is also one Spearman rank correlation is there. For academic exercise, all these methods you can use and you can do. Okay, so this is how the scatter diagram it shows. Okay, so that is when R equal to 0.80, then they have a positive correlations. When 0.4, positive, moderate positive correlation. When equal -1, there is a perfect negative correlation. When -8, negative correlations. When R equal to -0.2, weak negative correlations. When the R equal to 0, no correlation. So that means from this scatter diagram, the movement you can assess the degree of correlations. That is one method. But the best method of the, like in quantitative, if you want to find out correlations, the technique is summation xy by summation s square y square root over, or in a assuming method, n summation dx by dy minus summation dx summation dy by n summation ds square minus summation dx whole square root by n summation dy square minus summation dy square whole square, that you can find out this. Okay, so then in the interpretation is same. If the positive is a positive correlations, if negative correlation, you get 0, then there is a no correlation. There are different types of techniques through which you can do the correlation coefficients. So the the coefficient determination actually found out by R square. So R square shows that the next type of is coefficient determination. Then when I'll teach regression, that I'll teach you. Okay, these are the things I am skipping because I want to go to regression analysis now. So now the simple concept of correlation is known to you, and in the class room, when you teach correlation, we teach 2-3 classes by taking examples and doing different methods by Pearson correlation, Spearman line correlations. We don't have that much of time, but I want to do the regression. Regression, I have already spoken about the like regressions. So in regressions, you get the regression line that is known as y on x. So where y equal to dependent variable and x is equal to independent variable, y equal to, where a equal to intercept, b equal to coefficient, x equal to independent, b equal to dependent variable. So what is intercept? Intercept shows from the mathematical point of view when the line start. Beta shows what? It shows the coefficient, means rate of change in dependent variable due to change in the independent variable, which is measured by the tan theta. Tan theta is nothing but what is it is p by b, that is perpendicular by base. Okay, that is perpendicular base. I can show from like what is that one diagram is there. Yes, it is coming. What is that diagram? Anyway, so that you have seen the diagram, like when like on the 45-degree lines, that means your intercept equal to 0. But as a mathematical concept, your intercept can be 0. But as a theoretical from social science, your intercept cannot be 0. Your intercept always should be like some amount. Like any techniques you take, why intercept should be some amount? Because if you take intercept some amount, it will show you that from your line start. For example, if you take a simple examples like your growth and investment. If your growth is dependent variable and investment is a independent variables, like even if you don't do any investment, there is some amount of growth or some amount of investment. Like, sorry, there will be some amount of investment. That
It will
means,
be autonomous. That
yeah. So, but in mathematical sense, if you make x equal to 0, so like that, and there will be no intercept term, that can be possible. But in a social science, you need to have some amount of intercept. That means some amount of growth will be there if your investment equal to 0. For example, if you take the relationship consumption and income, even if your income, like in a consumption, your dependent variable is consumption and independent variable income. Even if your income equal to 0, your consumption variable will be what? There will be a minimum sum amount of consumption. If you for example, if you lose your job, a lot of people in COVID, they lost their job, but some amount of money they need to survive. So in the theoretical sense, it cannot be actually 0. Okay, is it clear? So there are some basic, this is what that basic concept I wanted to throw, that now when I'll go for like regression analysis, like time series analysis, that you need to understand that are the basic concept of regressions, that is assumption of regressions. Anybody there in that, what are the main 10 assumption of the regressions?
yes, sir.
Yes.
There should be no multi-collinearity. There should be no autocorrelation. X value should be independent of the residual term. There should be not explanatory value should not be related to each other.
Okay, so that regressions, we'll talk about the regression, but because in the maximum quantitative analysis, before understanding regression, we should understand the time series data, then we should understand the assumption of OLS. Okay, so as you know that there are two sources of data, primary sources and secondary sources. Also, there are also, if you divide the time, like your data types divided into 3 types. One is cross-sectional data, the second one is time series data, the third one is panel data. Okay, so the first data is cross-sectional data. Those who are working in sociology, anthropology, education, public administrations, and they are doing that, they are developing a questionnaire. First, they are developing a questionnaire, they are doing the pilot survey, they are doing the reliability and validity analysis. They are considering that their data is pertaining to a particular period. That means if today is 1st December, means that will be one period only. Okay, so that is known as cross-sectional data. So the cross-sectional data is more applicable to the primary data collections. It is not that primary data collection cannot be a time series data. Yes, the primary data collection can be a time series data. If you a primary survey, you can survey repeatedly. Like today you are surveying 4 people, tomorrow you are, for example, today you are surveying 50 people, tomorrow is another 50, then day after tomorrow you are doing another 100, then after you are doing another 200. Like you can do for a quite substantial period of time, like 30-40, then that can become a time series data. But generally,
Actually, is there any difference between longitudinal data analysis and time series data analysis?
yeah, I'm going to that. Please hold on. So that is known as cross-sectional data. Okay. So, but when you are coming to the time series data analysis, so there are some time interval is involved. That means it may be the year, it may be month, it may be days, it may be hour, it may be minutes. Like now, if you talk about stock market, in 1 minute also in the stock market, that is 60 fluctuation is there. That can also become the time series data. So that the time involvement is there. So the last type of data is known as panel data. So when you actually combine cross-sectional data and time series data, we call it pool data. Okay. when only simply we combine cross-sectional data and panel data, we call it pool data. But when this cross-sectional data time series we combine and the same cross-sectional data for separate for the specific time period again and again, for the same cross-sectional data we collect, for example, for the 28 state, for the data from 1950 to 2024 for Odisha, then for Bihar. So the time period is fixed, and we are again and again collecting the data for various cross section. That is your state, cross states, cross country. That become your panel data. So again, the panel data is divided into two types. One is balanced panel, another is unbalanced panel. If the for the same time period again and again you survey, it is known as balance panel data. But there is some unbalanced panel data is also there. But for example, in like some corporate, like if you are doing the cross company data analysis, some company does not give the variable for like some of the variables. So if some of variable is available in some company, it is not available in some other company, that is known as unbalanced panel data. But what happened in the pool data is the pool data, when you combine the time series and cross section data, and only your degree of freedom increases. That your time series increases, but that is you don't take that cross sectional data again and again. That become the pool data. Okay. So what you told that in the longitudinal time, that what you do, that same cross sectional data for a longer period of time you used to take, and you do the analysis. Okay. So I've already told that. So, but before understanding that, you need to understand the time series. Okay. So as you tell, time series consists of set of observations that are measured in the specific time interval. So if I tell in more technical time series follows stochastic variables which is a random in nature. So if there is a random variables which are occurring, so time series particularly is a random variables which is stochastic in nature. For example, sales figure of individual business or complete industry, or gross national product and other macroeconomic measures. So it is all these random variables. So any time series data you come across, so there are four types that you will get it. It may be a secular trend. The second one is seasonal trend. The third one is cyclical trend. The fourth one is random or irregular variations. So secular trend is the actual basic type is like a trend analysis. If I talk about this is a secular trend, like any data you put in diagrams and you try to understand how the movement is there, and there is no particular pattern is followed, we call it a secular trend. So that means here you try to observe the trend analysis. Is it clear what is secular trend? Then come to the seasonal variations. So in the seasonal variation, what happens in the data in every seasons or every month or every year, if you follow the same type of characteristics, we'll call a seasonal variation. For example, your GDP, the quarterly GDP increases due to the monsoon season. Your umbrella sales increases in the rainy seasons. Your ice cream sales increases due to summer season. Your woolen cloth sales increases during winter season. So this is called seasonal variations. So when a particular pattern followed during a particular times, it may be month or it may be year or it may be some days of a month, we call it a seasonal variation. So when you have a seasonal effect, that we make it deseasonalized by giving the some words to that. The second types of variations in the like time series is known as cyclical variations. Am I audible?
Yes, sir. Yes, sir. You are audible, sir.
Yeah. So the third type of variation, time series variation is cyclical variations. So this cyclical variation is specifically due to the business cycle. As you know that our economics students, they understand. Those who are not from economics background also they can understand. Our business cycle is like a cycles. You have a inflations, then deflation, then recession, then improvement. Then again you have a inflation. Then first you have a inflations, then you have a boom. Like when the price is increasing the above the normal region, it will keep on increasing and it will reach in the highest point. That is known as boom, because the Reserve Bank of India is there by exercising his monetary policy. Then it will bring down your price sense after a certain region. So rise in price doesn't mean the continuously to rise. So it will reach in a maximum point, that is known as boom. Then it will fall, that is known as deflations. And the fall in the rise price above the normal curve, it is known as deflations. And again up below the normal price level, when the price is falling, that is known as recession. If the price increases above, then that is below the normal level, it is known as improvement. When the price increases above the normal price, which call is inflation. So these are the circles it goes on in a economy. So if you are in inflation, so the time series data they're telling, if you are in a inflation type, the price will be like that price will increase. If you are in the recession period, then continuously there will be like there is no output, there is no employment, the price is less. So depend upon like what type of like cycles you are facing. So the time series data depend upon the what type of business cycle you are. Like during COVID time, then maximum country there was a recessions. So the time series nature of time series data, I will see that it's keep on, like if you see the World Bank data or UNCTAD data in like time. So from 1991 to 2022, all these GDP investment, all these actually there is a downward sloping curves. So this is due to the cyclical variation. No, even if that investment was happening, but due to the nature of the business cycle, it shows the downward sloping curve. So that was the nature of time series. The last type of time series, like nature of the time series, is that random or irregular variation. What is random or irregular variations? Means these are erratic, and this is due to the natural calamities. It may be earthquake, it may be flood, it may be famine, it may be what we call it earthquake, famine, floods, or tornado, something like that. It's, for example, in Turkey before 2-3 years in Turkey there was a huge earthquake was there. In Japan there is a huge earthquake was there. So then when the earthquake will be there, GDP will be less, investment will, the entire economy is devastated. Or if there is a flood, in Bihar every year there is a flood is there. In Odisha every year there is a cyclone is there. So these are the irregular or random variation in the time series analysis. Is it clear to you? Because like before understanding time series, you should understand what is the component of time series. Okay. So in a technical term, time series is an example of stochastic process. So the stochastic process is the collection of variable ordering time. Like when you use the probability concept, like when you throw the dice or touching the coin or playing the card. So there is a probability that every like when you toss the coin, there is a probability that head and tail have the equal probability of occurrence. So in the playing dice also, there is a 1 to 6 number is there. So that is a probability, equal probability that 1 to 6, that equally that they have equal probability they can occur. Okay. So stochastic process is stationary. So from the like technical point of view, the first properties of time stochastic process is that it should be mean should be constant, variance should be constant, and covariance are independent from the time lag. So this is that is expectation of u equal to constant, expectation of u square equal to constant, expectation of ui to uty is not equal to 0. Okay. So that means, so like But in the from a layman point of view, those who are from sociology and education and from public administration, so what stationary process shows? Stationary process shows that there should not be a huge ups and downs in the data. So data में ज़्यादा fluctuation नहीं होना चाहिए. If there is a more fluctuation in data, that is not stochastic process. That means that is some amount of fluctuation is there, but that amount of fluctuation should be within the band. That means when you talk about the inflations, so there is a in our economics there is a thumb rule is there 2 like 4 plus minus 2. 4 plus minus 2 means 4 minus 2 equal to 2, 4 plus 2 equal to 6. If the inflation actually fluctuated from 2 to 6%, so the inflation is under control. So from 2.1 to 5.9, that fluctuation is allowed. So that is not actually non-stationary. So that is stationary. That means this type of fluctuations is stationary. But if any type of fluctuation is beyond 6, below 2, that is non-stationary. You understand what is the stationary process in a time series? That means wide fluctuation should not be there. Because I told what are 3 properties of mathematical properties: mean equal to constant, variance is constant, covariance and independent from time lag. But the main concept in the layman point of view is that it should be within a band. Is it clear?
Yes, sir.
Yeah. So in the time, like since this regression is a concept, takes the concept of time series, there are a lot of researchers when they do the like those who are in the initial stage of there. So any regression you are doing without doing testing the stationary, if you are doing regression, that is wrong. So that means you are doing, so that means that you are not calculating regression in the proper manner. Okay. So if the series is non-stationary, then behavior studies for only that period under consideration cannot be generalized. So there is a forecasting problem. Okay. Or you can also cannot run the regression. The fact is that you should ensure that your time series should be stochastics. Sorry, stationary. If you are like any software you take, either it is Excel or Stata or eViews or Minitabs or R, you do any data you take and do the regression analysis, it will give some result. But the result itself is wrong because you have not checked the stationary. Okay, if 2 variables are not stationary and you are doing regressions, that is known as spurious or nonsense regression. Is it clear? So the first thing is that when you are doing a simple regression, even if 2 variable regression is that, we should do the stationary test. Okay. So the first thing is that before doing stationary tests, so there are 2 types of tests is that. One is like you do the simple, either you do the simple plotting and from there you understand if there is a more fluctuation is there or not. And the second is that you need to do correlations like correlogram. Correlogram is the graphical representation of the stationary. So there is a 2 like I can do practicals once if I have some times I can show you in the eViews that if that is within the band, so then there is no stationary. Also there are some mathematical test is there, that is Dickey-Fuller test, augmented Dickey-Fuller test and Phillips-Perrin test. With the help of mathematical test we can test the stationary also. That also for the time being I'm taking pause on that. But before that I just wanted to tell you what are the assumption of OLS. So the first assumption of OLS is that it should be linear in parameters. Linear means that what the parameters you are taking, it should not take any square of that. So it is a linear in nature. So if it's not linear, so it's a non-linear in parameters, we cannot do the what? Regression, that is a OLS techniques. The second assumption is that error terms are, for example, if you write one variables like this y equal to alpha and beta and this, and if that ut terms actually is not normal, so what happens? So then the ut should be normally distributed. Normal distribution means it should follow the bell shape. Yes, it should follow the bell-shaped curves. So that means UT is nothing in the time series. It is known as error terms or stochastic store or random variables. For example, this UT, like if delta YT equal to function of T and YT1, this is the auto-regressive term. When here UT shows that error terms, that apart from YT minus 1, what are the other variables actually which are affecting YT? So the second thing is that UT should be a normal, it should be follow the normal distributions. The third assumption of the regression is that it follows that there should not be any multicollinearity. So there is a difference between multicollinearity or correlations. If there is a correlation among the independent variable, we call it multicollinearity. That means if there is a 2-3 independent variable and they have some amount of correlations, we call it there is a multicollinearity is there. So that means why the multicollinearity is not actually allowed in the regression analysis, because if you allow the multicollinearity, then you cannot do the impact analysis, distinct impact analysis of the two variables. Like I'm giving an example. If you want to do the analysis of the impact of investment and the income, wealth, and investment on like growth of a person, like how the person is growing on the basis of, so that means your income and wealth somehow they are related. For example, if you are talking about, you are taking example that impact of growth on investment and foreign direct investment and foreign institutional investment, somehow foreign institutional investment is a part of gross capital for part of investment, and some, for example, foreign exchange reserve. Well, the foreign exchange reserve is also increased due to the more inflow of FDI. So what you have to do, you have to see the correlation between all these macroeconomic variables. What is the correlation between FDI, foreign exchange reserve, gross capital formations, inflation, any variables you are taking. But in the social science, when you take the qualitative variables, we don't face this problem often. But in a quantitative analysis, quantitative data analysis, when we are doing simple regression analysis, there is a correlation between the independent variable. When there is a correlation between the independent variable, we call it multicollinearity. That means the correlation between independent variable is only multicollinear, but the correlation between independent variable and dependent variable is not multicollinear. That is simple correlations. Okay. So in what this OLS assumption tells that we should not allow any correlation between the independent variable. Why? If you allow any correlation, though it shows that two variables somehow they are correlated. Like if is R you get the 0.6, that means 60% they are correlated. If they are 60% they are correlated, why you are taking two variable again? So somehow one variable is included in others. But in social science, you cannot make the two variable is total separate. So somehow correlation is there. So as a rule of thumb, in a correlation, we allow 30% correlation between the variables. So that means before doing any analysis in the regression analysis, we do one correlation matrix analysis. What is correlation matrix analysis? The variables which you take, like 4 variables, you take the corresponding analysis. If the correlation between X, like if you have X, Y, X1, X2, X3, in the right hand you take X, Y, X1, X2, left hand also you take X, Y, X1, X2, X3, and you get some, like if it's 0.8, that means they have a 80% similarities there. So you drop that variables. Only you take the variables which are correlation coefficient is below 0.3%. Okay, that is known as multicollinearity problem. So the multicollinearity problem that is there. So then I'll come simultaneously also I'm talking about how you can mitigate that multicollinearity problem. So if you face the multicollinearity problem, so there are the various reasons of that multicollinearity. The first reason is it may be that you have taken irrelevant variables. That means those variables are not, suppose you are not supposed to take, you have taken, that's why it is showing the multicollinearity. That means another reason why multicollinearity is there, you have, it might be taken some of the variables which are not relevant variables also. That's why also multicollinearity happens. Also multicollinearity happens maybe that they to the actually you take some measurement error also. So these are the terms for actually why you face the multicollinearity problem. So there are 2-3 types of remedies there when you can you can remove the multicollinearity. Before remove the multicollinearity, you should know how the multicollinearity is there. So to understand multicollinearity, the first technique is that if you're in a multiple regression, if your t value some very few t value are statistic, but a variable are statistically significant, but some t value is statistically insignificant, so that shows there is a multicollinearity is there. Okay, or also you have a VIF test is there, various inflected factor test is there. So there is a formula 1/1 minus VI R squares. So that R square is nothing but correlation coefficient. If the variance inflected factor is there, is close to 1, then there is no multicollinearity. So if there is so either you do the VIF test, or condition number you do, or condition index you do. From that you can understand the multicollinearity. By using that multicollinearity, so you can remove the multicollinearity. So by removing multicollinearity, there are some techniques that the first technique is that you can drop the irrelevant variable. The second technique is that for multicollinearity is that you can include the necessary variable, then some places the multicollinearity problem is solved. The third type is the multicollinearity is that you can do the factor analysis. In the factor analysis, what you do, you combine some of the variables and make one factors. That's how you actually mitigate the multicollinearity problem. I think you understand the multicollinearity problem now, and how to remove the multicollinearity problem. Generally, in economics class, we take one class to teach the multicollinearity. Since we don't have that much of time here, so I have to told what are the main things in the multicollinearity. Am I audible?
Sir, what is the difference between Dickey-Fuller and augmented Dickey-Fuller test, sir? इंटरव्यू में पूछते हैं ये वाला छोटा सा क्वेश्चन.
So in the Dickey-Fuller test, and Dickey-Fuller test is also one mathematical test of testing the stationarity. In a Dickey-Fuller, actually both the techniques are actually discovered by Dickey and Fuller. But what happens in the Dickey-Fuller test, there is a problem of autocorrelation is there. And what happens in augmented Dickey-Fuller, by taking the lag of your dependent variable, we remove the problem of autocorrelation. That's I'm talking. I have not come to that. That's why I'm not spoken, because after multicollinearity I'll talk about autocorrelation. So let me talk autocorrelation, then I'll talk why use the augmented Dickey-Fuller. Okay, give sometimes. Then the next type of assumption is autocorrelations. The regression also talks then. That's why that augmented Dickey-Fuller is coming to the place. In the autocorrelation, so the correlation between the error term. That means the UT has a series. U1, for example, if you have like 50 observations, so this UT equal to U1, U2, U3, U4 up to U50. So the correlation between U1, U2, U3 up to U50 is known as autocorrelations. So this autocorrelation generally happens due to the lag behavior of the observations. So this autocorrelations is the lag variable observation. So we dictate autocorrelation with the help of Durbin-Watson statistics. So Durbin-Watson statistic is equal to 2 into 1 minus rho is equal to Durbin-Watson statistics. So if the DW statistic is close to 2, then there is no autocorrelation. If DW statistics goes up to 4, then there's negative autocorrelation. If DW statistics goes near to 0, then there is a positive autocorrelation. So DW statistic should be equal to 2, or somehow from 1.8 to 2.2. But generally, it's an ideal situation that you will not get DDoL statistic always like 2, but if you are getting more than 1.8 and 2, that is also expected, or from 2 to 2.5 also that is expected. So that means there is no autocorrelation is there. But if there is a autocorrelation is there, then that is the biggest problem. That's why the stationary test, when your decoupler was telling there is a autocorrelation problem is there. So in order to remove that autocorrelation, you take the augmented decoupler test. So in the augmented decoupler test, we actually remove the autocorrelation by taking the lag of that. You can see that. See.
Thank you, sir.
Just you see this equation. Delta yt equal to beta 1 beta 2t plus beta 2 yt minus 1 summation alpha I delta yt minus 1, and I actually raised 1 to m. So that means this is the summation forms of the delta yt. By taking the lag of delta yt and adding in the independent variable, actually we are solving the problem autocorrelation in case of decoupler test. So that's why decoupler test is more accurate compared to the augmented decoupler test. I think you got the concept why we use the augmented decoupler test. Is it clear? So the fourth assumption of this OLS is that the important assumption that is also related to your error term is that it should be the homoscedasticity. So homoscedasticity actually comes from the two words. The one is homo, the second is scarcity. Homo means equal, scarcity means spreadness or scatteredness. So that means if there is equal spreadness or equal scatteredness, we call it homoscedasticity. Okay. So that means the variance of the error terms, if there is equally that is scattered, we call it homoscedasticity. So this in the regression, it shows that it should be a homoscedasticity. If there is a heteroscedasticity, then there is a problem. So we have to remove the heteroscedasticity by using the GLS method. So GLS method is nothing but it is the transfer form of OLS methods which actually satisfy all the assumption of the OLS, and you do the GLS by doing some amount of transformations. You do the reciprocal transformation by dividing a common number, you can do that, or by multiplying a number, you can do that. By any type of transformation, if actually your OLS, it will make GLS, and by using GLS, actually you remove the problem of heteroscedasticity. So the testing the heteroscedasticity, there are a lot of tests is there. Bruce Pagan Gottfried test is also there. That test actually in Hebrews it shows that by using that there is null hypothesis there, that data follows heteroscedasticity, and the alternative hypothesis that the data follows homoscedasticity. So if you
excuse me, sir. Yes, sir. Can we apply WLS in case of a heteroscedasticity problem?
WLS means
Wortel least square method.
Yeah, Wortel least square method also you can. That is also another methods of heteroscedasticity. I told one of the Bruce Pagan is one of the. There are more than 4 or 5 methods is there to remove the heteroscedasticity. So GLS is the one of the most important. So Wortel least square also you can do that. By giving weightage, you can use that also you can do that. Then the fourth, fifth assumption of the OLS. Yes.
Sir, can we use this in qualitative data or quantitative data only?
This is for quantitative. Quality data, that's what I'm telling you. So today is the topic of discussion is quantity data analysis. Yes.
So for qualitative kind of data, we go for normality test, right?
Qualitative, no. Qualitative analysis, we go for 2 tests, that is reliability test and validity test. Okay. So when you have a qualitative data, you go, because today my topic of discussion is not, can I know who is speaking?
Sir, it's Vaishali.
Okay. So Vaishali, you have asked actually very good questions. For qualitative data, because today is that quantity data analysis is my sphere of presentations, but I can tell for the qualitative data, when you are collecting the qualitative data, you have data on binary variables, you have a data on Likert part scale, you have a data on nominal variable, you have data on ordinal variables. So there, what you first you do that, you do the reliability test. That is Cronbach alpha. Okay, in that Cronbach alpha, what you when you do the pilot testings, by taking the questionnaires, what you do the reliability test of all these questionnaires, all your questionnaires. If your like Cronbach alpha is greater than 0.6, then the data your question, that variable is valid, then all these variables can test, and in the pilot state that you can pass, then you can show to supervisor, then you can go for a sample size analysis. That is for qualitative, but this is only for quantitative data analysis when you have a time series analysis. Is it clear? For qualitative, the first things you can do the reliable data analysis. So reliable data analysis, SPSS is there, and other software is also there, and it uses Cronbach data analysis. After doing reliability, you can do validity analysis also. Okay, your questionnaire valid or not, like that you can do. Okay, clear?
Okay, this test can be carried out in SPSS, no?
SPSS is this decoupler, augmented decoupler is not there, and it doesn't give the good result, even if the new version is not is there. But generally, this like result of this stationary test gives better result in eViews and Stata. Okay, generally either you can use eViews, Stata, or R. R is open source software that you can do that, but in R a little bit you have to use the R Studio, a little bit of code you have to use. But in Stata also you can use code, otherwise Stata is also a menu driven package, and eView is also a menu driven package. Okay, that you can do that.
Okay, sir. Thank you.
So then I was talking about what I was talking about in the sixth assumption of the like this equation is that there is a endogeneity problem is there. Endogeneity problem is that means if there is a relation, if there is association between the independent variable and the error term, so the covariance between the error term and independent variable is not allowed in regressions. Generally, maximum researcher actually omit that one. So if you are allowing the correlation between the error term and independent variable, that is the problem of endogeneity. So if there is a problem of endogeneity, is that if you are running regression, that is a biased result. You don't get the consistent result. So for that reason, there is a special techniques is there. You can use GMM techniques. You can use instrumental variables for removing that. Okay. Then seventh assumption of
Hello, sir.
that,
Hello, sir.
yes.
Sir, can you tell us a little bit of instrumental variables, sir?
Yeah, the little bit instrument variable is that for examples, if you are taking two like one dependent variable more than one independent variables, okay, and after doing the endogeneity test, you came to know that like y is the function of x1, x2, x3, x5, and plus ut is there. Okay, if there is a relation, by doing the correlation matrix between the x1, x2, x3, x4, and ut, you came to know that there is a relation between x3 and u. Okay, so that means there is a relation between one independent variable and a error terms. So what will happen, instead of that x3, you include another variable which is similar to your x3. Okay, yes, similar
Yes, sir,
to
yes.
x3, but that is not a x3. Please listen. And by adding another variable which is known as x5, which is like somehow more correlated to x3 but not exactly x3, and you include that. For example, you are using income, and income is related to the error term. Instead of income, you take now wealth, or instead of income, you take investment. Somehow now you'll see there will be no correlation between the error term and independent variable. That is known as instrument variable. So instrument variable is look like a independent variables, but when there was that you get correlation between independent variable and error terms, but by including another variable which is similar, to the independent variable, but not that independent variable. We are trying to find out another instrumental variable which exactly same, not same, but some maximum property characteristics of that variable it carries. So that is known as instrumental variable.
Is it like incorporating proxy variables? That
Yet exactly that you take one proxy variables. Instrumental variable is like you take one proxy variables. Okay.
Another thing I have doubt. What are the tests? But the test you didn't identify for identifying endogeneity problem in a regression model. What tests we have to follow?
So there are a lot of statistical tests is there for like endogeneity problem. So that is a one endogeneity test is that Watson Jenkins test is there. Another is like panel that also you use, that I have forgotten, that you can do that. Okay. So Watson test is a very famous test for endogeneity test. Okay.
We will refer. Thank you.
So then after endogeneity, that another problem of correlation is that specification bias. Okay. So generally what you researcher do that if you don't give the correct specifications, you actually commit the specification bias. Nobody, like in econometrics, we do the technical analysis. Specification bias includes three problems. One is when you include the unnecessary variables. The second is when you include when you include unnecessary variables. Second is when you have left the necessary variable. Third is when there is a measurement error. Measurement error means that there is a scaling error. That means regression does not do the comparison between the like different scales. That means in the independent variable, if you have a rupees crore, and independent variable you have a kg, you have a dollar, you have a kilometers, you have a index number. So you cannot compare one kg with the rupees crores. So what you have to do, all these variable you have to bring a common scale. That means either you do the logarithm transformations or any type of transformation to bring to a common scale, then you can do the comparison. Otherwise, what regression shows, the change in the dependent variable due to change in independent variable. How much the changing the like kilograms, how much change in the rupees, it's very difficult to do that, or index number, something like that. So that's why you do the logarithm transformations. Okay. So the next assumption of the OLS is that number of observations should be the number of variables. This is what the problem of degree of this is where the problem of degree of freedom arises. So if there is a more degree of freedom, so what will happen? Your result will be more robust. Generally, the rule is that if your observation is less than your your constant use, that you cannot run the regression. So the thumb rule is that for one variable you should have a minimum 40 variables. So like means if you have 6 variable, you should have minimum 246 for the 240 observation. Otherwise, you will not get good result. That's why when you have a degree of freedom, that is the basic assumption why basic necessities, why instead of time series you are shifting to panel data analysis, because in panel data you get more degree of freedoms. For example, if I now know people are doing the like impact of COVID analysis, but if you do the time series COVID analysis, because now the COVID ended, only 3 years is there. So 3 years you cannot do any analysis. For if you want to do for 30 states, and now you have a now you have a 4 to 5 years post COVID period is there. So 5 into 30 you can get 150 observations. So you 150 observation you can do a good panel, like not very good panel, but panel analysis you can do. That's why your number of observations should be the number of constant used. The number of constant means number of independent variable plus your intercept terms. That is what the technical terms we call it, number of constant used in the independent variable. So this is what assumption of the OLSU text. Then the third mathematical test of the stationary is your Phillips parent test. So Phillips parent test is a non-parametric test. The Phillips parent test is a non-parametric test. And this decupular and augmented decupular is a parametric test. Can anybody tell what is the difference between parametric and non-parametric test?
So in case of parametric data are normally distributed. In case of non-parametric data are not normally distributed. That is the first feature of parametric and non-parametric test.
You are somehow partially correct, but not only normal distribution. See, the simple definition between parametric and non-parametric is that when your distribution is known to you, then you can use the what parametric distribution, like whether it's a normal distribution or a Poisson distribution or a logistic distribution or binomial distribution. When the distribution is different, you will use the different techniques. Okay, is getting my point?
Yes, sir.
When your distribution is not known to you, you have not tested which distribution it is, that you can use the Phillips parent test. Is it clear?
Yes, sir.
So normal distribution is included in that distribution, that your basically you do the test in the normal distribution. So that means your distribution normal is known to you, and since OLS actually use now, because there are a lot of parametric tests also used in the probability distribution. Lot of parametric tests also you use in the binomial distribution also. Lot of non-parametric tests also you use in the logistic distribution also. So for normal distribution, if the normal distribution is used, then you can use decupular and augmented decupulars. Got my point? It's not only normal distribution, the distribution is known to you. And in case of regression, your normal distribution, that assumption is normal distribution, so the normal distribution is known to you, so that's why you can do either decupular or augmented decupular. Or if it's a distribution, you have not tested distribution, so directly you can use the Phillips parent test. Is it clear?
Yes, sir.
So these mathematical things I'm not going. So also in the Phillips parent also there is a solve the problem of heteroscedasticity also. Then come to the last item of my today's discussion is Ganser causality. Okay. So initially when you was actually doing the causality analysis, we are not taking the lag of the variables. But Ganser, what you have done, he has actually used the lag of the different variable as the lag of the own variable. That's why this the Ganser causality has become very famous. If you talk about any macroeconomic variables in the time series analysis, like this year growth actually depend upon not only the previous year growth, also previous year investment or previous year inflation. Am I right or not? If you only talk about the instantaneous relation, y is the function of x, that means y depend upon x. That means growth depend upon investment, but growth depend upon investment. Otherwise, also the investment of the previous year, also the growth of the previous year. So, what the Ganser is test that if you tell that y is causing x, y is actually influenced by the lag of his own lag as well as lag of the independent variables. For example, if the investment is causing growth, means growth is caused by investment, lag of investment as well as lag of the growth. Because if we talk about the major project, so whatever provision is given in the budget, some investment is done this year and or it goes to next year, then it goes to the next 2 years. Then, like if I'm giving the simple examples in J&K, in Jammu and Kashmir, I have been listening. There is one railway project construction is going on for connecting Jammu to Kashmir. You might have, everybody have listened about this. You have heard about this, that will be 10 connectivity from Jammu to Kashmir. For last 15 years, that construction is going on. That means before, like if you go to the lag of 15 years, what investment has done in the last 15 years, till today that output has not been produced, that has been not converted in the growth. Am I right? Or even if you talk about the major infrastructure project, it takes 2-3 hours. Normal project takes 2-3 hours, took 2-3 years to convert to the output. So that's why the growth of the current year depend upon that. Like that means if the growth of the current year depend upon the previous year growth, that means for a Ganser causality it depend upon the past lag as well as the lag of the dependent variable. Okay. So the Ganser causality test is statistical hypothesis, which actually given by C.W. Ganser in 1969. It is the famous article Investing Causal Relation by Econometrics Model and Cross-Spectral Method, which is published in Econometrica in 1969 in the volume 37 issue 3. This is a path-breaking research he has done, where he shows this is the model. Okay. Can you see this slide? Is this slide is visible to everybody?
Yes.
Yes,
Yes,
sir.
yes, sir, yes.
Those who are from like other background, I'm just I'll talk about that like in a simple way. I'll speak, then I can tell the mathematical integrity of that. So this, the first equation itself showing that growth of GDP depend upon the lag of growth of GDP and the lag of growth of FDI. Like if that GDP is depend upon lag of GDP, and so we can call in FDI is causing GDP if that GDP, the growth of GDP is influenced by the growth of GDP as well as the lag of FDI. So if you read the first equations, growth of GDP is the intercept plus summation I raised from 1 to P UI growth of GDP T minus 1. So it shows that from 1 to P, that is it is only coefficient. Also the coefficient of FDI. Like that, if we write FDI is the function of also lag of FDI, and the summation term I raise from 1 to n is go up to m, and also the lag of the growth rate. Now your assumption is that if I make in the first equations, if I make summation j raised from 1 to q rho j equal to 0, that means the coefficient of 0 will be, coefficient of FDI will be 0. Am I right? So if this coefficient, can you see this? I'm just keeping my cursor here. If this coefficient will be 0, that means j1 to q rho j equal to 0. That means this will be 0 and the FDI will be 0. So that means FDI is not causing the growth. And if this will be not 0 and it will have some non like positive value, that means h1 equal to summation I q p rho j is not equal to 0. That means some positive numbers. That means this will be the lag of FDI will cause the growth rate. And obviously it understood growth rate, the lag term has influence. Also, this has also the second equation also in our null hypothesis equal to h0 equal to j1 to n, delta 0 equal to 0. So if your delta 0 equal to delta j equal to 0, so then it is, I hope everybody know the hypothesis. Yes? Anybody in this group doesn't know that inferential statistic, that hypothesis? If you not, then I can go a little bit explain and I explain this. Anybody please raise your hand, those who doesn't know the hypothesis. If somebody is there like that? Saurabh?
Yes,
Somebody,
sir.
is
Yes,
anybody
sir.
there? They're telling I don't know.
Shali just raised her hand.
Yes. Is somebody is writing? Okay. Then little bit hypothesis I can explain, then I can come to that. Is the statistical test is clear? Is visible to you?
Yes, sir.
Yes, sir.
So, as you know that hypothesis is tentative assumption of supposition which you need to prove or disprove. So you need to understand what is the difference between hypothesis and statement. So generally in the day-to-day conversations, when you talk about hypothesis, when you talk about like statement, when you do conversation, we keep on throwing statement. These are known as statement. But hypothesis is a tentative suppositions or assumption which you need to prove it. Like if I tell like Saurabh is a bad boy, so I have to prove it. If I cannot prove Saurabh is a bad boy, so I cannot tell. So that means my statement is not significant. Getting my point? So in the hypothesis testing, there are two types of hypothesis there. One is null hypothesis, another is alternative hypothesis. The null hypothesis is a false hypothesis and alternative hypothesis is a true hypothesis. Okay. So there is a process that if you reject null hypothesis, then you expect alternative hypothesis. That process is known as significant. That test is significant. If the reverse happens, if you expect the null hypothesis and reject the alternate hypothesis, that is non-significant. And in technical terms, how it happens, if our calculated value is greater than tabulated value, we call it significant test. If the calculated value is less than tabulated value, we call it insignificant test. Is it clear? That is what when I was teaching Ganjar causality, I wanted that this technical things you should know it. Anyway, maximum student also they know it. So that's why this H0 is null hypothesis and H1 is an alternate hypothesis. So if you reject null hypothesis, means alternative hypothesis is true, that is H1 is true, that means rho has some values. Okay. In the second case also, if you reject that delta value and expect that H1, that means delta has some coefficient. That means growth rate is actually impacting the FDI. Okay. So when you do the Ganjar causality test, it shows the two-way correlation. So here you can see the typical examples that growth does not Ganjar causality is significant. That means here you can reject null hypothesis, expect alternate hypothesis. That means FDI is causing growth rate. So here the result is FDI is causing growth rate. Okay. So this is what I wanted to tell, and another important concept I can also explain, that which is that common to quantitative analysis, that is known as vector auto regressions. Anybody can tell what is VAR, vector auto regressions? This is one concept actually you use in data analysis. So generally in the regression analysis, we have a dependent variable and independent variable, or endogenous variable and exogenous variable. But in VAR, we don't have an endogenous variable and exogenous variable. So in VAR, every variable has chance to become independent variable and dependent variable. So that is in the VAR. If there is 8 variables is there, so you can have 8 dependent variable. So it is a structure of like models where there is no endogenous and exogenous variables. And the most important merit of the VAR is that VAR is a theoretical model. Maximum model we are using in the data analysis is a theoretical model. That means any empirical, as somebody was telling, sir, whether you will make how will know some variable is dependent and independent variable, that actually comes from a theoretical background. Okay. If you don't have any theoretical background, the VAR is the best method from where actually you use to actually bring the theory. So VAR is a powerful techniques where actually you give a theory. Okay. So what happens in the VAR, from data we give the theory. So that's why now a machine learning techniques or big data world, VAR is the important concept where from a data we give the theories. Like you have a data of the 10 variables, there is some theories there, but according to your data, some result you are getting and you try to interpret in that. So this variable is affecting this variable. So that's why this variable has positive relation with this variable. This variable has positive negative relation. For example, I will give you simple examples. Like generally, people believe that FDI is causing more growth. Like in some places, that it has been seen by using the data, FDI is causing the negative impact on the growth. So this is how this VAR is giving the result that no, in some cases, theory, actually our analysis is not lying, is not corroborating with the theory, and from the from the data we are getting the different result. So the VAR is a theoretical model. So that means behind the VAR there is no theory is there. So another like usefulness of VAR is that VAR is used for a policy response variable. That means when you disturb one variable, how it has impact on different variables. Since it is used on macroeconomic data modeling, so VAR used for policy response. Like in a monetary economics or any other social science, like the time series data, you tell that when you disturb one variable, how it has impact on other variable. If you want to know, you can use the VAR. By different, like same variable, it gives some positive result. Like if you take FDI in the growth, it will give positive impact. But when you take growth and impact or growth and impact, it maybe gives the negative result. Another application of VAR is the structural VAR. In structural VAR, what you do that we do a little bit of simulation analysis, like keeping other factor constant. If you vary one variable and you are trying to find out what are the impact on the main variables, that is called impulse response functions. So in the impulse response function, if you want to find out, there are variables like money supply, inflations, and GDP. These are three variables, and apart from that also you have a 6-7 variable. You have exchange rate, you have a like the call money rate, you have a what do you call it, you have interest rate, and there are, and from your from your past experience you understand this, like your interest rate and foreign exchange rate, and it does not have more impact of like when you change the repo rate, and you want to know what is the impact when you changing in the repo rate, what is the impact on that is on only money supply and inflation. This is called monetary economics. For example, if for using for social science context in the time series variable, there are so many variables is there in social science, but you want to know by changing one variable what is the impact on mainly 2-3 variables. There you can use a structural VAR model, and by using the structural VAR model you can see what are the policy response in all these variables. So that means you can understand when you are changing one variable, what is the impact on mainly 2-3 variables. And by using various decomposition, you can understand what is the main source of that variations in case of VAR. So those who want to detail, who want to study, so you can use the VAR, structural VAR, and you can read that. So this is what from my side, and VAR is also used for doing forecasting, or also VAR also used for like problem, solve the problem, degree of freedom. Now I can open the house for discussion. We can we have more than 1 hour. We can now do the discussion. If have some queries, I'll be happy to answer all these queries.
Am I audible, sir?
Yes.
Yes. Good afternoon. It was a good session, sir. Sir,
Thank
I
you.
want to ask on methodology 2-3 points.
Yes, please.
In our study, we have taken bank merger, pre-merger and post-merger scenario, performance and non-financial performance study. So out of 12 public sector banks, we have chosen only in 6 cases there have been mega merger. So our sample is probability based 6, or out of 12 we are taking 6. So which kind of sampling it is? I understand probability based.